The morning mist hung thick over Firebase Charlie in Tay Ninh Province as Sergeant First Class Michael Torrino of the 1st Infantry Division's 2nd Battalion crouched behind a fallen mahogany log, his M14 rifle slick with condensation. It was February 15th, 1965, and the 24-year-old paratrooper from Brooklyn had no way of knowing he was holding America's shortest-serving battle rifle in his hands, or that within 36 months, the weapon would be declared obsolete and shipped back to storage depots across the continental United States. The enemy was out there, somewhere in the green maze of rubber trees and elephant grass that stretched beyond the perimeter wire. Intelligence reports suggested a reinforced company of People's Army of Vietnam regulars, armed with the legendary AK-47 assault rifles that had already earned a fearsome reputation among American advisors. Torrino adjusted his grip on the M14's walnut stock, feeling the weapon's 10.1 pounds of steel, and with a comforting weight that reminded him of the M1 Garand his father had carried through the hedgerows of Normandy 21 years earlier. What Sergeant Torrino didn't know was that his rifle represented the final evolution of a weapons philosophy that traced its roots back to 1896 and the Springfield Krag-Jorgensen. The M14, officially designated United States Rifle Caliber 7.62mm M14, had been designed for a different kind of war, the kind of war that American military planners had expected to fight against Soviet tank columns rolling across the North German plain, where its 7.62 by 51mm NATO cartridge could reach out and touch an enemy at 800 meters with devastating authority. But Vietnam wasn't Europe, and the jungle didn't care about theoretical engagement ranges or NATO standardization agreements signed in comfortable conference rooms in Brussels. The jungle cared about close-quarters fighting, about ambushes that erupted at ranges measured in tens of meters rather than hundreds, about weapons that could put massive volumes of fire downrange in the first crucial seconds of contact. And in that environment, the M14's single greatest advantage, its powerful full rifle cartridge, became its most crippling disadvantage. The story of the M14 begins not in the steaming jungles of Southeast Asia, but in the sterile conference rooms and testing ranges of the 1950s, when the United States Army Ordnance Corps was desperately trying to design a rifle that could serve every possible role in every possible conflict. The project had been 15 years in the making, tracing its lineage back to experimental modifications of the M1 Garand during the final months of World War II. The goal was ambitious beyond reason: create a single weapon that could replace the M1 Garand rifle, the M3 grease gun submachine gun, the M1 carbine, and the M1918 Browning automatic rifle. One rifle to rule them all, in the parlance of a later generation. The result was a weapon that did none of those jobs particularly well, a compromise that pleased accountants and logisticians while frustrating the infantrymen who had to carry it into battle. Springfield Armory in Massachusetts initiated production of the M14 in April 1958, after nearly 15 years of research and development that had consumed millions of dollars and countless man-hours. The product of this Herculean effort was undeniably impressive on paper. A gas-operated, magazine-fed rifle that could deliver accurate semi-automatic fire out to 500 meters and beyond, with selective fire capability for close-quarters work and a 20-round detachable box magazine that was a significant improvement over the M1 Garand's 8-round en-bloc clips. But even before the first production rifles rolled off the assembly line, problems were becoming apparent. The primary complaints were consistent across multiple testing sites: fragile receivers that cracked under stress, malformed bolts that caused extraction problems, poor accuracy in full automatic mode, and most critically, virtually uncontrollable recoil when fired on full auto. Some soldiers compared the M14 in full automatic mode to trying to control an anti-aircraft gun. The muzzle would climb so violently that after the first 2 or 3 rounds, the rest of the magazine would be aimed at the tree canopy rather than the enemy. Quality control issues plagued early production. The complex manufacturing tolerances required for the M14's operating system proved difficult to maintain at the production volumes the Army demanded. Initial production rates were glacially slow, with Springfield Armory struggling to produce enough rifles to meet even basic training requirements. By 1960, when American military advisors were beginning to arrive in South Vietnam in significant numbers, most of the United States Army was still armed with World War II-era M1 Garands. The solution to the full automatic control problem was elegantly simple and militarily devastating. Limit 90% of all M14 rifles to semi-automatic fire only. The selective fire capability that had been one of the rifle's primary selling points was essentially eliminated from service, leaving American infantrymen with what was essentially a modernized version of their father's M1 Garand, heavier, more complex, and firing a cartridge that was only marginally more powerful than the old 30-06. Private First Class Anthony Benedetto of the 25th Infantry Division learned about the M14's limitations the hard way during a patrol sweep near Siuchi on November 23, 1965. The 19-year-old draftee from Queens had been in country for exactly 6 weeks when his squad stumbled into a well-prepared ambush that would become a textbook example of why the M14 was fundamentally wrong for jungle warfare. The enemy opened fire from positions less than 50 meters away, their AK-47s chattering in full automatic bursts that sent a wall of 7.62 by 39mm rounds crashing through the undergrowth. Benedetto dropped prone behind the roots of a banyan tree and tried to return fire with his M14, but the rifle's 20-round magazine was empty within seconds, and in the chaos of the firefight, reloading was a nightmare. The M14's magazine was designed for deliberate, aimed fire at long ranges, not for the kind of high-intensity, close-quarters combat that characterized most engagements in Vietnam. While Benedetto fumbled for a fresh magazine, the Viet Cong were already shifting positions, their AK-47s providing continuous suppressive fire that kept the Americans pinned down. The communist weapons' 30-round magazines and reliable full automatic capability gave them a decisive advantage in the kind of fast-moving, aggressive tactics that define jungle warfare. But the magazine capacity was just one part of the problem. The M14's weight was becoming a critical issue as American troops adapted to the unique demands of Vietnam combat. At 10.1 pounds loaded, the rifle was nearly 3 pounds heavier than the AK-47, and in a combat environment where soldiers routinely carried 80 to 100 pounds of equipment through difficult terrain and temperatures that frequently exceeded 100 degrees Fahrenheit with humidity levels approaching 100%, every ounce mattered. The M14's walnut stock, beautiful in peacetime and perfectly adequate for European combat, became a liability in the tropical environment of Vietnam. The wood would swell and warp in the constant humidity, affecting the rifle's accuracy and reliability. Soldiers reported that their M14s would shoot to different points of impact depending on the weather conditions, making it impossible to maintain consistent zero, a critical problem for a weapon that was supposed to excel at long-range precision fire. More fundamentally, the M14's entire design philosophy was wrong for Vietnam. The rifle had been conceived during the height of the Cold War, when American military planners envisioned World War III as a series of massive conventional battles fought across the open terrain of Central Europe. In that environment, the ability to engage targets at 600 to 800 meters would have been invaluable. But Vietnam's dense jungle canopy limited visibility to ranges measured in tens of meters rather than hundreds, negating the M14's primary advantage while emphasizing its weaknesses. Inside the brick buildings of Springfield Armory, the reality of the M14's production problems was becoming increasingly apparent to the engineers and workers who were trying to manufacture the rifle in the quantities the Army demanded. William Henderson, a 43-year-old machinist who had worked at Springfield since 1946, watched the quality control reports pile up on his supervisor's desk with growing concern. The M14 was a precision instrument, requiring manufacturing tolerances that were achievable in small quantities but problematic at mass production scales. Each rifle required over 200 individual machining operations, many of them holding tolerances measured in thousandths of an inch. The gas system, derived from the proven M1 Garand design, was robust and reliable, but it was also complex and expensive to manufacture correctly. Henderson's team was responsible for machining the receivers, the heart of every M14. The process began with forged steel blanks that weighed nearly 12 pounds each more than the finished rifle, which were then machined down to the precise dimensions required for the rifle to function. Each receiver required nearly 6 hours of machine time on the latest Cincinnati milling machines, and even then the rejection rate hovered around 8%. The bolt was even more problematic. The M14's rotating bolt system required extremely precise manufacturing to ensure proper headspace and timing. Henderson had seen entire production runs scrapped because the bolt faces weren't machined to the correct specifications, a costly mistake that sent ripples throughout the Army's procurement system. By 1962, Springfield Armory was struggling to produce even 15,000 rifles per month, far below the Army's stated requirement for 60,000 rifles monthly. The problem wasn't just technical, it was also economic. Each M14 cost the government approximately $95 to manufacture, compared to $37 for an M1 Garand. The increased cost was justified by the rifle's enhanced capabilities, but those capabilities were proving to be less valuable than anticipated in actual combat conditions. Quality Control Inspector Margaret O'Sullivan, who had worked at Springfield since the World War II production surge, noticed troubling patterns in the rifles coming off the assembly line. Receivers were cracking at stress points that hadn't been problems in testing. Barrels were showing inconsistent accuracy characteristics. Most concerning, the automatic fire mechanism was proving to be fundamentally flawed, not just difficult to control, but actually dangerous to the operator in some circumstances. The root of many problems traced back to the M14's ambitious design goals. In trying to create a weapon that could serve every possible role, the designers had created a rifle that was too complex for mass production and too compromised for any single mission. The automatic fire mechanism, in particular, was a source of constant problems. The rifle's stock design and weight distribution made controllable automatic fire nearly impossible, but the mechanism itself was fragile and prone to malfunction under field conditions. By 1963, internal Army reports were beginning to acknowledge what the men at Springfield had known for months. The M14 was not suitable for mass production using existing manufacturing techniques and equipment. The tolerances were too tight, the materials requirements too demanding, and the overall design too complex for wartime production needs. While Springfield Armory struggled with the M14's production problems, a small aerospace company in California was developing a radical alternative that would eventually replace America's troubled battle rifle. Armalite, a division of Fairchild Engine and Airplane Corporation, had been founded with the explicit goal of bringing aerospace materials and manufacturing techniques to small arms design. The company's chief engineer, Eugene Stoner, was a former Marine who had learned his trade in the aircraft industry rather than traditional firearms manufacturing. This background gave him a fundamentally different perspective on rifle design, one that emphasized weight reduction, manufacturing efficiency, and modular construction over the traditional approach that had dominated military small arms since the 19th century. Stoner's AR-15 rifle represented a clean-sheet approach to the infantry weapon problem. Instead of trying to adapt existing designs or manufacturing processes, he started with a blank piece of paper and asked a simple question. What would a rifle look like if we designed it using 1950s technology and manufacturing techniques rather than 1940s approaches? The answer was revolutionary. The AR-15 used aircraft-grade aluminum alloys for the receiver, reducing weight while maintaining structural strength. The barrel was chrome-lined for durability and corrosion resistance, a technique borrowed from artillery manufacturing. The stock was made from fiberglass-reinforced plastic, virtually impervious to moisture and dimensional changes. Most radically, the rifle fired a new cartridge, the 5.56 by 45 mm round that delivered adequate terminal performance while weighing significantly less than traditional full rifle cartridges. The ammunition question was crucial to understanding the AR-15's advantages. The 5.56 mm cartridge weighed less than half as much as the M14's 7.62 NATO round, which meant soldiers could carry more ammunition for the same weight penalty. In jungle combat, where resupply was often difficult and firefights were characterized by high rates of ammunition consumption, this advantage was enormous. Robert Fremont, a ballistics engineer at Armalite, had spent months developing the optimal bullet design for the 5.56 cartridge. The final result was a 55-grain bullet that achieved devastating terminal effects through velocity rather than mass. When the bullet struck a target at high velocity, it would fragment and tumble, creating massive wound channels that were often more effective at stopping an enemy than the larger, slower bullets fired by traditional rifles. The manufacturing advantages were equally impressive. The AR-15's modular design meant that it could be assembled from subcomponents manufactured at different facilities, reducing the bottlenecks that plagued traditional rifle production. The aluminum receivers could be manufactured using existing aircraft industry tooling and techniques, while the plastic components could be molded rather than machined, a process that was both faster and more consistent than traditional methods. By 1962, Armalite had demonstrated that the AR-15 could be manufactured at a rate of over 50,000 rifles per month, using existing industrial capacity nearly 4 times the production rate that Springfield Armory was achieving with the M14. The cost advantages were equally dramatic. Each AR-15 cost approximately $47 to manufacture, roughly half the cost of an M14. The story of how the AR-15 became the M16 is as much about corporate politics and military bureaucracy as it is about technical innovation. In December 1959, facing financial difficulties and skeptical about the military market for their radical new rifle, Armalite sold the manufacturing rights to the AR-15 to Colt's Patent Firearms Manufacturing Company for the sum of $750,000 plus royalties. For Colt, the acquisition represented an opportunity to enter the military rifle market after decades of focusing primarily on handguns. The company's president, William Sturtevant, recognized that the AR-15's advanced design and manufacturing advantages could give Colt a decisive edge in the competition for military contracts that were expected to run into the hundreds of millions of dollars. James Sullivan, who had worked on the AR-15's development at Armalite before joining Colt, oversaw the transition of the rifle from prototype to production weapon. The process required significant modifications to accommodate Colt's existing manufacturing capabilities, while maintaining the rifle's essential characteristics. The most visible change was the relocation of the charging handle from under the carrying handle to the rear of the receiver, a modification that improved the rifle's ergonomics while simplifying manufacturing. The early AR-15s produced by Colt were impressive weapons that demonstrated clear advantages over the M14 in several key areas. The rifle weighed only 6.5 pounds empty, nearly 4 pounds less than the M14, and its straight-line stock design made it much more controllable in full automatic fire. The 20-round magazines were lighter and more reliable than the M14's magazines, and the rifle's overall length was 4 inches shorter despite having a 20-inch barrel. But perhaps most importantly from a military perspective, the AR-15 proved to be supremely suited to the kind of rapid, high-volume manufacturing that modern warfare demanded. Colt's production engineers quickly discovered that they could manufacture AR-15s using a combination of traditional machining, investment casting, and modern plastics technology, a hybrid approach that combined the best aspects of each manufacturing method. The rifle's upper and lower receivers were manufactured using aircraft industry techniques, with tight tolerances maintained through precision machining and careful quality control. The bolt carrier group required sophisticated manufacturing capabilities, but once the tooling was established, the components could be produced rapidly and consistently. The handguards, pistol grip, and buttstock were injection molded from high-strength plastics, a process that was both faster and more consistent than traditional woodworking. By 1963, Colt was producing AR-15s at a rate that exceeded Springfield Armory's M14 production by a factor of 3 to 1. The cost advantages were equally impressive. Each AR-15 cost the government $63, including Colt's profit margin, compared to $95 for an M14 that was becoming increasingly problematic in both manufacturing and field use. The AR-15's entry into military service came through an unexpected channel. The United States Air Force, which was looking for a lightweight rifle for its security forces and air-based defense units. Air Force Chief of Staff General Curtis LeMay had gained first-hand experience with the rifle during a July 1960 demonstration at Arlington Hall, where Eugene Stoner himself had demonstrated the weapon's capabilities. LeMay was impressed not just with the rifle's technical specifications, but with its practical advantages for Air Force operations. Air-based security required weapons that were light enough to be carried for extended periods, reliable enough to function in diverse climatic conditions, and powerful enough to engage targets at the ranges typically encountered in perimeter defense missions. The AR-15 met all of these requirements while offering significant logistical advantages over existing weapons. The Air Force's initial order for 8,500 rifles in 1962 represented the AR-15's first major military contract, and it provided Colt with the production experience and credibility needed to compete for larger Army contracts. More importantly, it gave American military personnel their first extensive field experience with the weapon that would eventually become the standard infantry rifle for all services. Colonel Walter Yates, who oversaw the Air Force's small arms program, was particularly impressed with the AR-15's performance in tropical environments. Unlike the M14, which suffered from stock warping and corrosion problems in high humidity conditions, the AR-15's aluminum and plastic construction proved to be virtually immune to environmental degradation. Air Force security units stationed in Southeast Asia reported consistently positive experiences with the rifle, even under the demanding conditions of tropical deployment. The Air Force's experience with the AR-15 also provided crucial data about the rifle's ammunition requirements and logistical footprint. The 5.56mm cartridge proved to be remarkably efficient in terms of weight and volume, allowing security forces to carry significantly more ammunition while reducing the logistical burden on supply systems. A basic load of 210 rounds weighed less than half as much as the equivalent load of 7.62 NATO ammunition. But perhaps most importantly, the Air Force's AR-15 program demonstrated that the rifle could be manufactured, fielded, and maintained using existing military infrastructure. The weapon's modular design meant that maintenance could be performed at the organizational level using standard tools and procedures, while major repairs could be handled by existing small arms repair facilities with minimal additional training. The AR-15's first combat trials in Southeast Asia came through the Military Assistance Command, Vietnam Studies and Observations Group, better known as MACV-SOG. This highly classified Special Operations Unit was tasked with conducting unconventional warfare missions throughout Southeast Asia, and its operators were given considerable latitude in selecting their equipment and weapons. In May 1962, 1,000 AR-15 rifles were shipped to Vietnam for field testing by ARVN, Army of the Republic of Vietnam, units and American Special Forces advisors. The results were remarkable. After firing 80,000 rounds in various field trials, the test rifles experienced 0 parts breakages and required only 2 replacement parts across the entire 1,000 rifle sample. Master Sergeant Francis Romano, a Special Forces advisor working with ARVN units in the Mekong Delta, filed reports that praised the AR-15's performance in jungle conditions. The rifle's lightweight was a significant advantage during long-range patrols that might last several days, while its reliability in high humidity conditions surpassed that of any other American small arm. Most importantly for special operations use, the rifle's full automatic capability was actually controllable, allowing operators to place effective suppressive fire on target during contact. The ARVN troops who used the AR-15 during these trials were equally enthusiastic. The rifle's weight was particularly appreciated by Vietnamese soldiers, who were generally smaller in stature than their American counterparts and found the M14 to be uncomfortably heavy for extended operations. The AR-15's balance and handling characteristics were well suited to the kind of quick reaction engagements that characterized much of the fighting in Vietnam. Perhaps most tellingly, enemy reaction to the AR-15 was markedly different from their response to other American weapons. Captured documents and prisoner interrogations revealed that Viet Cong and North Vietnamese units had developed specific tactics for engaging M14 armed American forces, based on their understanding of the rifle's limitations in close-quarters combat. But the AR-15's different characteristics, particularly its sustained fire capability and lightweight, disrupted these established tactics and forced enemy units to adapt their procedures. The 5.56mm cartridge's terminal effects were also proving to be more devastating than traditional full rifle rounds in jungle combat. The high-velocity bullet's tendency to fragment and tumble after impact created massive wound channels that were often immediately incapacitating. Wounded enemy soldiers frequently required evacuation by multiple carriers, removing additional combatants from the engagement, a force multiplication effect that was particularly valuable in the small unit actions that characterized special operations. By late 1962, MACV-SOG operators were requesting additional AR-15 rifles to replace their aging M1 carbines and captured enemy weapons. The rifle's performance in actual combat conditions had convinced even skeptical Special Forces veterans that the lightweight weapon represented a significant advance in infantry firepower. Secretary of Defense Robert Mcnamara's decision to adopt the AR-15 as the standard American military rifle was based on a combination of battlefield reports, cost analysis, and his characteristic reliance on quantitative data to drive major procurement decisions. By early 1963, the evidence against the M14 had become overwhelming, while the case for the AR-15 was supported by extensive field testing and favorable cost comparisons. The financial considerations alone were compelling. Each M14 cost $95 to manufacture and required extensive quality control measures that were proving difficult to implement at production scales. Springfield Armory's production rates remained far below requirements, while cost overruns were threatening the entire rifle program. In contrast, Colt's AR-15 cost $63 per rifle and could be manufactured at significantly higher rates using existing industrial capacity. But Mcnamara was equally influenced by the battlefield reports coming from Vietnam and other testing sites. The M14's fundamental unsuitability for jungle warfare was becoming increasingly apparent as American involvement in Southeast Asia expanded. The rifle's weight, limited magazine capacity, and uncontrollable automatic fire were serious disadvantages in the kind of combat that American forces were increasingly likely to encounter. The AR-15's advantages extended beyond simple performance characteristics. The rifle's modular design meant that it could be easily adapted for different missions and requirements, a valuable capability for a military that was beginning to recognize the need for operational flexibility. Special operations variants could be configured with shorter barrels and collapsible stocks, while standard infantry versions could be optimized for general-purpose use. Mcnamara's staff analysis, completed in January 1963, concluded that adopting the AR-15 would save the government over $200 million compared to continuing M14 production while providing superior combat capability. The analysis also noted that the AR-15's manufacturing base could be expanded more rapidly than M14 production, providing better support for potential mobilization requirements. The decision to halt M14 procurement was announced on January 19, 1963, with instructions for the Army to begin transitioning to the AR-15 as quickly as possible. The new rifle would be designated the M16 and would incorporate several modifications requested by the Army, including a forward assist mechanism and chrome-plated chamber to improve reliability in adverse conditions. The Army Ordnance Corps' reaction to Mcnamara's decision was swift and vehemently negative. For decades, the Ordnance Corps had controlled military small arms development, and the AR-15's adoption represented a fundamental challenge to their institutional authority and technical philosophy. The rifle hadn't been developed through traditional Army channels, and its radical design violated many of the principles that had guided American small arms development since World War I. Colonel Frank Conway, who headed the Army's Small Arms Development Program, filed a series of reports criticizing the AR-15's design and questioning its suitability for military use. Conway's primary objections focused on the rifle's use of lightweight materials, its dependence on high-velocity ammunition, and what he characterized as inadequate testing under realistic combat conditions. The Ordnance Corps' resistance took several forms, some more subtle than others. Test protocols were designed to emphasize the AR-15's weaknesses while minimizing its advantages. Comparative tests between the M14 and AR-15 often used match-grade M14 rifles against standard production AR-15s, skewing results in favor of the older weapon. Most significantly, the Ordnance Corps insisted on modifications to the AR-15 that would compromise its essential characteristics while adding complexity and cost. The most damaging change was the decision to switch from DuPont IMR 8208M stick powder to Olin Matheson WC 846 ball powder in the 5.56mm ammunition. This change was made for logistical reasons. The ball powder was more readily available and could be manufactured using existing facilities, but it had catastrophic effects on the rifle's reliability and performance. Ball powder burned at a different rate and produced higher chamber pressures than the stick powder that had been used in all of the AR-15's testing and development. The increased pressure caused accelerated wear in the rifle's gas system and contributed to extraction problems that would plague early M16s in Vietnam. More seriously, the powder change increased the rifle's cyclic rate from approximately 750 rounds per minute to over 1,000 rounds per minute, making the weapon less controllable and more prone to malfunction. Major Richard Thompson, who served as a liaison between the Ordnance Corps and Colt during the M16's development, later testified that Army officials were aware that the powder change would cause problems but proceeded anyway. The decision was justified on the grounds that existing military ammunition manufacturing facilities were tooled for ball powder production, and switching to stick powder would require expensive retooling and delays. The first M16 rifles began reaching American forces in Vietnam in late 1964, but the weapons that arrived bore little resemblance to the AR-15s that had performed so well in earlier testing. The Army's modifications, combined with the ammunition problems created by the powder change, had transformed a reliable and effective weapon into a source of constant frustration and danger for the soldiers who depended on it. Private First Class David Martinez of the 1st Infantry Division received his M16 at Bien Hoa Air Base on December 3, 1964, during his unit's initial in processing. The 20-year-old draftee from El Paso had trained with M14 rifles at Fort Benning, and his first impression of the M16 was mixed. The rifle was undeniably lighter and more maneuverable than the M14, but it felt fragile and insubstantial compared to the solid steel and walnut of the older weapon. Martinez's platoon sergeant, Staff Sergeant James O'Brien, a Korean War veteran who had carried an M1 Garand through 2 tours in the Pacific, was openly skeptical of the new rifle. O'Brien had heard rumors about the M16's problems from other units, and his initial inspection of the weapons revealed several concerning issues. The rifles had been shipped without cleaning kits or lubricants, and the accompanying technical manuals were incomplete and contradictory. More seriously, the rifles had been marketed to the troops as self-cleaning weapons that required minimal maintenance. This was a catastrophic misrepresentation of the M16's maintenance requirements, which were actually higher than those of previous American military rifles. The direct gas impingement system, while simpler than traditional gas piston designs, required regular cleaning and lubrication to function properly, particularly in the high-temperature, high-humidity conditions of Vietnam. The first indication of serious problems came during Martinez's unit's initial combat operation, a search and destroy mission in War Zone C on January 8, 1965. The operation began routinely, with Martinez's platoon conducting a sweep through dense jungle terrain that limited visibility to less than 50 meters. Contact was initiated by enemy forces using the classic L-shaped ambush formation that had become standard for Viet Cong and North Vietnamese units. Martinez dropped prone and attempted to return fire with his M16, but the rifle jammed after firing only 6 rounds. The bolt had failed to extract the spent cartridge case, leaving the rifle completely inoperable until the case could be removed manually, a process that required several minutes and left Martinez effectively disarmed during the critical opening phase of the firefight. Similar problems were occurring throughout Martinez's platoon. Of the 12 M16 rifles in his squad, 5 jammed during the first few minutes of the engagement. The soldiers attempted to clear the jams using techniques they had learned with the M14, but the M16's different operating system required different procedures that hadn't been covered in their limited training on the new weapon. The primary cause of the M16's jamming problems was a phenomenon that became known as failure to extract, the rifle's inability to remove spent cartridge cases from the chamber after firing. This problem was directly related to the Army's decision to switch ammunition powders and their refusal to chrome plate the rifle's chamber despite Colt's specific recommendations. The WC-846 ball powder produced significantly more fouling than the IMR powder that had been used in testing. This fouling built up in the chamber and on the bolt face, creating a sticky residue that interfered with the rifle's extraction system. More critically, the ball powder's higher pressure curve caused the cartridge cases to expand more forcefully against the chamber walls, making extraction more difficult. Without chrome plating, the steel chambers quickly developed microscopic pitting and corrosion that further complicated extraction. The high humidity and temperature conditions in Vietnam accelerated this process, with some rifles showing significant chamber degradation after only a few hundred rounds. Soldiers reported that their M16s would function acceptably when clean and dry, but would begin jamming after extended periods in the field. Sergeant Michael Kowalski of the 25th Infantry Division documented the extraction problems in a letter to his wife that was later quoted in congressional hearings on the M16's failures. "Out of 40 rounds I fired," Kowalski wrote, "my rifle jammed about 10 times. I pack as many grenades as I can plus bayonet and K-bar so I'll have something to fight with. If you can, please send me a bore rod and a 1 1/4 inch or so paintbrush. I need it for my rifle." The bore rod request was particularly telling, as it indicated that soldiers were being forced to drive stuck cases out of their rifles using cleaning rods, a dangerous and time-consuming process that left them vulnerable during firefights. The M16's original design included no provision for manually removing stuck cases, as the rifle had been expected to function reliably under all conditions. Technical Sergeant Robert Harrison, an Army small arms specialist who was deployed to Vietnam to investigate the M16's problems, filed reports documenting the scope of the extraction issues. In one representative sample, Harrison tested 50 M16 rifles that had been in service for 6 months and found that 37 exhibited some form of extraction problem. Most concerning, 12 rifles had chambers so severely damaged by corrosion that they were considered unsafe to fire. The extraction problems weren't just a matter of inconvenience, they were killing American soldiers. Enemy forces quickly learned to recognize the sound of an M16 jamming and would time their attacks to take advantage of the temporary reduction in American firepower. Several documented cases exist of American casualties that occurred while soldiers were attempting to clear jammed rifles during firefights. As the M16's problems became more widespread, American servicemen began writing home about their experiences with the troubled rifle. These letters, many of which were later obtained by Congressional investigators, provided a stark contrast to the official reports that were being filed through military channels. Marine Lance Corporal Thomas Brennan wrote to his parents in Boston from a firebase near Danong. "The M16 is a jamming piece of garbage. In our last firefight, 3 guys in our squad had their rifles jam at the same time. Kowalski got shot while he was trying to get a cartridge out of his chamber. These rifles are getting guys killed, and nobody seems to care." Army Specialist Jerome Washington wrote from Cu-Chi, "I don't trust this rifle at all. Half the time it works fine, but the other half it jams right when you need it most. The enemy knows about our rifle problems and they're taking advantage of it. We're starting to use captured AK-47s whenever we can get them, because at least they work when you pull the trigger." The AK-47 comparison was particularly damaging to the M16's reputation. The Soviet-designed rifle, while heavier and less accurate than the M16, was proving to be significantly more reliable in jungle conditions. Enemy forces had been using AK-47s in Southeast Asia since the late 1950s, and the weapon had developed a reputation for functioning reliably even under the most adverse conditions. Marine Corporal James Delvecchio wrote from Kisan, "We picked up some enemy rifles after the last attack, and they're in much better shape than our M16s even though they've been in the jungle for months. The AK doesn't jam like ours does, and it keeps shooting even when it's dirty. I'm thinking about requesting an M14 if they'll let me have 1 inch." These letters began reaching American newspapers in early 1966, creating the first public awareness of the M16's problems. The Washington Daily News broke the story on March 26, 1967, with an article titled "M16 Rifle Called Unreliable" by GIs in Vietnam. The article included excerpts from soldiers' letters and raised serious questions about the weapon's suitability for combat use. The growing volume of complaints about the M16's reliability eventually reached the attention of Congress, where several members had received letters from constituents whose sons were serving in Vietnam. Representative James Howard of New Jersey, whose district included several military families, began collecting documentation of the M16's problems and demanding answers from the Defense Department. Howard's initial inquiries were met with bland assurances that the M16's problems were being addressed through normal channels, but the congressman wasn't satisfied with these responses. In May 1967, Howard requested a formal investigation by the House Armed Services Committee's Special Subcommittee on the M16 rifle program. The subcommittee, chaired by Representative Richard Ichord of Missouri, began hearings on May 15, 1967. The testimony revealed a pattern of institutional failures, bureaucratic infighting, and deliberate obfuscation that had contributed to the M16's problems. Most damning was the testimony of technical experts who had warned about the ammunition powder change but had been ignored by Army procurement officials. Eugene Stoner himself testified before the subcommittee, explaining that the AR-15 had been designed around the specific characteristics of IMR stick powder, and that changing to ball powder without corresponding modifications to the rifle was like putting diesel fuel in a gasoline engine and expecting it to run properly. Stoner's testimony made it clear that Colt and Armalite had specifically warned against the powder change, but had been overruled by Army officials. The subcommittee's investigation also revealed that the Army had failed to provide adequate training on the M16's maintenance requirements. Unlike previous American military rifles, the M16's direct gas impingement system required specific cleaning procedures and lubricants. Soldiers had been told that the rifle was self-cleaning, leading many to neglect basic maintenance that was essential for proper function. Perhaps most shocking was the testimony of Colonel Frank Conway, who admitted under questioning that the Ordnance Corps had been aware that the ammunition powder change would cause reliability problems, but had proceeded anyway for what he characterized as logistical convenience. Conway's testimony revealed that Army officials had prioritized manufacturing considerations over combat effectiveness, a decision that had directly contributed to American casualties. The Congressional investigation's findings led to immediate changes in M16 production and field maintenance procedures. The most important modification was the addition of chrome plating to the rifle's chamber and bore, a change that Colt had been recommending since early 1964, but which the Army had rejected as unnecessary. Chrome plating solved several problems simultaneously. The hard, smooth chrome surface was highly resistant to corrosion and fouling, reducing the extraction problems that had plagued early M16s. Chrome plating also made the rifle easier to clean and maintain, as fouling and debris could be removed more easily from the smooth surface. Lieutenant Colonel Harold Moore, who had led the 1st Battalion, 7th Cavalry Regiment during the Battle of Ia Drang, was one of the first field commanders to receive the improved M16A1 rifles in late 1967. Moore's unit had experienced significant problems with early M16s during their November 1965 engagement with North Vietnamese forces, and he was initially skeptical about the modifications. The new rifles proved to be dramatically more reliable than their predecessors. During a month-long operation in the Central Highlands, Moore's battalion fired over 100,000 rounds through their M16A1 rifles with only 12 instances of extraction failure, a reliability rate that was comparable to the best traditional military rifles and far superior to the early M16s. The M16A1 also incorporated several other improvements that enhanced its combat effectiveness. A forward assist mechanism, originally opposed by Eugene Stoner but insisted upon by the Army, allowed soldiers to manually seat the bolt in cases where fouling or other problems prevented complete closure. While purists argued that the forward assist was unnecessary in a properly functioning rifle, it provided psychological reassurance to soldiers who had experienced problems with earlier versions. The rifle's flash suppressor was redesigned to reduce muzzle flash and provide better balance for the weapon. The new design was particularly effective in reducing the bright muzzle flash that had made early M16s visible to enemy forces during night operations, a critical improvement for a rifle that was increasingly being used in low light conditions. Most importantly, the M16A1 was accompanied by comprehensive training materials and cleaning kits that addressed the maintenance problems that had plagued earlier versions. Soldiers received detailed instruction on the rifle's operating system and specific cleaning procedures, while unit armorers were provided with specialized tools and training for performing more complex maintenance tasks. While conventional forces were struggling with early M16 problems, special operations units were developing their own solutions through the CAR-15 program. The Colt Automatic Rifle 15 was a family of shortened rifles designed specifically for special operations use, and it represented the first successful adaptation of the AR-15 platform for specialized mission requirements. The CAR-15 program began in 1964 when the Military Assistance Command, Vietnam Studies and Observations Group requested a lightweight, compact rifle for long-range reconnaissance missions. MAC-SOG teams operated deep in enemy territory for extended periods, and they needed weapons that combined the firepower of a full-sized rifle with the portability of a carbine. Master Sergeant Billy Waugh, who served 3 tours with MACV-SOG's Command and Control North, was among the first special operations personnel to receive the experimental CAR-15 rifles in mid-1965. The shortened rifle, designated XM177E1, featured a 10-inch barrel and collapsible stock that reduced overall length by nearly 8 inches compared to a standard M16. The compact rifle was immediately popular with special operations personnel. Its lightweight, only 5.8 pounds empty, made it ideal for long-range patrols where every ounce of equipment mattered. The shortened barrel sacrificed some ballistic performance, but at the ranges typical of jungle engagements, this was rarely a significant disadvantage. The XM177E1's most distinctive feature was its massive flash suppressor, a 4.2-inch device that served multiple purposes. The suppressor reduced the rifle's muzzle flash to manageable levels despite the short barrel, and it also served as a counterbalance that improved the weapon's handling characteristics. Most importantly for special operations use, the The suppressor slightly reduced the rifle's sound signature, making it less likely to reveal the user's position. Sergeant First Class John Plaster, who carried an XM177E2 during multiple MAC SOG missions, praised the weapon's reliability and effectiveness in his post-war memoirs. "The CR-15 never let me down," Plaster wrote. "It was light enough to carry all day without fatigue, reliable enough to function in any conditions we encountered, and powerful enough to handle anything we might face. For special operations work, it was the perfect weapon." The CAR-15's magazines were initially a problem, as 30-round magazines weren't available until 1969. Special operations personnel were forced to use 20-round magazines or to purchase 30-round magazines on the civilian market using unit funds, an irregular procurement method that was officially discouraged but unofficially tolerated. By 1967, Colt had developed the improved XM177E2 with an 11.5-inch barrel that provided better ballistic performance while maintaining the weapon's compact characteristics. The Army placed an order for 510 XM177E2 rifles specifically for MAC SOG use, making it one of the first weapons designed and procured exclusively for Special Operations Forces. While American forces were adapting to the M16's capabilities and limitations, a small number of Navy SEALs were experimenting with a radically different approach to the 5.56mm rifle. The Harrington and Richardson T223 was an American licensed version of the German Heckler & Koch 33 Hong Kong dollars rifle, and it represented a fascinating fusion of German engineering and American manufacturing capabilities. The T223 program began in 1965 when Harrington and Richardson, seeking to compete in the military rifle market, obtained a license to manufacture the 33 Hong Kong dollars roller-delayed blowback rifle chambered in 5.56 NATO. The German rifle used a completely different operating system than the AR-15, based on technology that traced its lineage back to World War II German developments. The HK-33's roller-delayed system was inherently more reliable than the AR-15's direct gas impingement system, particularly in adverse conditions. The rifle's operation depended on mechanical leverage rather than gas pressure, making it less sensitive to fouling and environmental conditions. This reliability came at a cost. The T223 was significantly heavier than the M16 and more expensive to manufacture. Navy SEAL Rudy Bosch of SEAL Team 2 was among the first American Special Operations personnel to use the T223 in combat. Bosch, who would later become famous as one of the oldest contestants on the television show Survivor, carried the German-designed rifle during multiple combat deployments to Vietnam's Mekong Delta region. Bosch's primary reason for selecting the T223 was its 40-round magazine capacity, double that of the standard M16. In the kind of high-intensity, close-quarters combat that characterized SEAL operations, this additional firepower was often decisive. The T223's reliable automatic fire capability was also superior to the M16's, providing sustained suppressive fire when needed. The rifle's manufacturing incorporated several improvements over the standard 33 Hong Kong dollars. Harrington and Richardson added a last-round bolt hold open feature and redesigned the bipod mounting system to better suit American tactical doctrines. The fire selector markings were changed from German to English, and the overall weapon was optimized for American ammunition and maintenance procedures. Production numbers for the T223 were extremely limited. Probably fewer than 1,000 rifles were manufactured during the entire production run. The rifle was expensive to produce and required specialized manufacturing techniques that Harrington and Richardson had difficulty scaling up. Most of the rifles went to Navy SEAL units, with smaller numbers used by other special operations forces. The T223's combat performance was excellent, but its limited production numbers meant that it had minimal impact on overall American small arms development. The rifle represented a fascinating what-if scenario, a glimpse of how American military rifles might have evolved if German engineering approaches had been adopted rather than the Armalite design philosophy. The international connections in Vietnam-era American small arms extended beyond rifles to include optical equipment that was crucial for precision shooting and target identification. The Colt Sporter scope, which became a popular accessory for M16 and CAR-15 rifles, was manufactured in Japan by Hakko Optics, a company that would later become Japan Optics Limited. The relationship between Colt and Hakko began in the early 1970s when Colt was seeking a manufacturer for high-quality, affordable optical sights for civilian and military use. Japanese optical companies had developed sophisticated manufacturing capabilities during the 1960s, combining traditional craftsmanship with advanced production techniques to create optical products that rivaled or exceeded European standards. Hakko Optics had been founded in the 1960s as a precision machinery workshop on the outskirts of Tokyo. The company's founder, whose background included work in Japanese camera and precision instrument manufacturing, recognized the growing international market for high-quality optical equipment. By the early 1970s, Hakko had developed the manufacturing capabilities and quality control procedures necessary to produce military-grade optical sights. The Colt Sporter scope was available in both 3-power and 4-power versions, with the 4-power scope becoming more popular due to its better performance at longer ranges. The scope featured a fine duplex reticle paired with a ballistic drop compensator that was calibrated for 55-grain 5.56mm ammunition fired from a 20-inch barrel. Staff Sergeant Michael Romano of the 5th Special Forces Group was among the first American soldiers to use Hakko-manufactured Colt scopes in combat. Romano purchased his scope through unit funds in late 1972 and mounted it on his XM177E2 carbine for use during reconnaissance missions in the Central Highlands. The Japanese-manufactured scope proved to be remarkably durable and reliable under combat conditions. The optical quality was excellent, with clear, bright images that maintained their clarity even after months of exposure to tropical conditions. The scope's mechanical components, including the elevation and windage adjustments, functioned smoothly and held their settings even after being subjected to the shock and vibration of combat operations. Romano's scope survived multiple firefights, several helicopter crashes, and countless hours of jungle operations without requiring any maintenance beyond basic cleaning. The scope's sealed construction proved to be completely weatherproof, with no fogging or moisture intrusion even during extended periods in high humidity conditions. The ballistic drop compensator was particularly useful for special operations personnel who needed to engage targets at varying ranges without time for complex range estimation and scope adjustment. The compensator was calibrated to provide accurate hits out to 400 meters with minimal holdover, which covered the vast majority of engagement ranges in Vietnam. By the mid-1970s, Hakko-manufactured Colt scopes were being used by American forces throughout Southeast Asia. The scopes were particularly popular with MACV SOG reconnaissance teams, Marine Corps snipers, and Army Special Forces units that required accurate fire at extended ranges. The Japanese manufacturing quality had proven to be equal to or better than American-manufactured optical equipment while being available at significantly lower cost. Italy's contribution to Vietnam-era American small arms development was less direct but equally important, coming through the NATO standardization process that had established the 7.62 by 51mm cartridge as the alliance's standard rifle ammunition. Italian military experience with full-power rifle cartridges, dating back to World War I, provided valuable data for the NATO Standardization Committee that established ammunition specifications. The Beretta BM-59 rifle, Italy's post-war service rifle, was essentially a modernized version of the M1 Garand chambered for the 7.62 NATO cartridge. Italian experience with this rifle provided important feedback about the cartridge's performance characteristics and manufacturing requirements, data that influenced American development of both the M14 rifle and its ammunition. Colonel Giuseppe Martinelli, who served as Italy's representative to NATO's Small Arms Standardization Committee, had extensive experience with full-power rifle cartridges dating back to World War II. Martinelli's reports on Italian military experience with the BM-59 included detailed analysis of the 7.62 NATO cartridge's performance in various climatic conditions and tactical situations. Italian ammunition manufacturers, particularly Fiocchi, had developed advanced manufacturing techniques for the 7.62 NATO cartridge that influenced American production methods. The Italian approach to propellant chemistry and case metallurgy provided technical solutions that were adopted by American manufacturers, improving the consistency and reliability of 7.62 ammunition produced in the United States. The Italian military's experience with the BM-59 in various international deployments provided valuable lessons about the limitations of full-power rifle cartridges in modern combat conditions. Italian reports noted that the 7.62 cartridge's weight and recoil made it less suitable for automatic fire than smaller cartridges, observations that supported American development of the 5.56mm cartridge for the AR-15. Captain Antonio Bianchi, an Italian Army officer who served as a liaison to American forces during joint NATO exercises in the early 1960s, filed reports that were influential in American thinking about rifle cartridge selection. Bianchi's analysis noted that engagement ranges in modern combat were generally much shorter than those for which traditional rifle cartridges had been designed, suggesting that lighter, smaller cartridges might be more appropriate for future conflicts. By late 1966, it had become clear that the demand for M16 rifles would far exceed Colt's initial production capacity. The company's Hartford, Connecticut facility was producing approximately 15,000 rifles per month, but military requirements called for at least 60,000 rifles monthly to support the expanding American commitment in Vietnam. Colt's response was to implement the most ambitious manufacturing expansion in the company's history. New production lines were established at existing facilities, while subcontracting arrangements were made with other manufacturers to produce specific components. The challenge was to maintain quality control while rapidly scaling production, a problem that had plagued many defense contractors during World War II. James Mitchell, who served as Colt's production manager during the Vietnam buildup, implemented innovative quality control procedures that ensured consistency across multiple production lines. Each rifle was subjected to function testing before shipping, while statistical process control techniques were used to identify and correct manufacturing problems before they could affect large numbers of weapons. The aluminum upper and lower receivers required the most sophisticated manufacturing techniques. Colt invested heavily in precision machining equipment, including new computer numerical control milling machines that could maintain the tight tolerances required for proper rifle function. Each receiver required over 4 hours of machine time on the most advanced equipment available, but the investment in modern machinery paid dividends in terms of quality and consistency. Harrington and Richardson was brought in as a second source for M16 production in 1967, adding another 15,000 rifles per month to total American production capacity. H&R's experience with the T223 rifle provided valuable insights into 5.56mm rifle manufacturing, and their production lines were able to achieve quality levels that matched Colt standards. General Motors' Hydromatic Division also became involved in M16 production, contributing their expertise in high-volume manufacturing and quality control. GM's automotive manufacturing techniques proved to be well-suited to rifle production, particularly for components that could be manufactured using existing automotive tooling and procedures. By mid-1968, total American production of M16 rifles had reached over 75,000 per month from all sources combined. This production rate was sufficient to equip not only American forces in Vietnam but also to provide M16s to Allied forces and to build up strategic reserves for potential future conflicts. The controversy over ammunition propellants that had plagued the early M16 continued throughout the Vietnam conflict, with technical experts and military officials debating the relative merits of different powder types. The issue was complicated by the fact that ammunition was being manufactured by multiple contractors using different propellants and manufacturing processes. The original AR-15 had been developed using DuPont IMR 8208M stick powder, a single base propellant that burned cleanly and produced consistent chamber pressures. This powder had been used in all of the rifle's testing and development, and it provided optimal performance for the 5.56mm cartridge when fired from the AR-15's 20-inch barrel. The Army's decision to switch to Olin Matheson WC-846 ball powder was made primarily for manufacturing convenience. Ball powder could be manufactured using existing facilities and equipment, while stick powder would have required significant investment in new production capacity. The decision was made without adequate testing of the ball powder's effects on rifle performance and reliability. Dr. James Harvey, a propellant chemist who worked for DuPont, filed extensive reports documenting the problems created by the powder switch. Harvey's analysis showed that ball powder produced significantly more fouling than stick powder, particularly in the high-temperature conditions typical of tropical combat. The fouling buildup interfered with the rifle's gas system operation and contributed to extraction problems. More seriously, ball powder burned at a higher pressure curve than stick powder, increasing the rifle's cyclic rate from approximately 750 rounds per minute to over 1,000 rounds per minute. This increase made the rifle more difficult to control in automatic fire and accelerated wear on critical components. The pressure differences also affected cartridge case extraction. The higher pressures caused brass cases to expand more forcefully against the chamber walls, making extraction more difficult, particularly when chambers weren't chrome-plated and developed corrosion or pitting. The combination of high pressure and fouling buildup created a perfect storm of extraction problems. Ammunition manufacturers eventually developed improved ball powders that addressed some of these problems, but the damage to the M16's reputation had already been done. The jamming problems that characterized early M16s were directly traceable to the ammunition powder decision, which had been made for logistical convenience rather than combat effectiveness. The Army's formal testing of the M16 at Aberdeen Proving Ground provided crucial data about the rifle's capabilities and limitations under controlled conditions. The testing program, conducted between 1964 and 1967, included extensive reliability testing, accuracy evaluation, and comparative analysis against other rifles including the M14 and captured enemy weapons. Colonel William Davis, who supervised the Aberdeen testing program, implemented the most comprehensive small arms evaluation protocol in Army history. The testing included over 2 million rounds fired through representative samples of M16 rifles under conditions designed to simulate combat use. Environmental testing included exposure to temperature extremes, humidity, dust, mud, and saltwater immersion. The accuracy testing revealed that the M16 was significantly more accurate than the M14 when fired in semi-automatic mode. The lighter rifle was easier to shoot accurately, particularly for smaller soldiers, and its straight-line stock design reduced muzzle jump between shots. Average group sizes at 100 meters were consistently smaller for the M16 than for the M14. Automatic fire accuracy was even more favorable to the M16. The rifle's lightweight and straight-line design made it much more controllable than the M14, which had been notoriously difficult to control when fired in automatic mode. Trained soldiers could keep M16 bursts on target at ranges up to 100 meters, while M14 automatic fire was generally ineffective beyond 50 meters. The reliability testing initially showed significant problems with early M16s, particularly those firing ball powder ammunition. Jamming rates of up to 12% were recorded during some test sequences, an unacceptable failure rate for a combat weapon. However, rifles using stick powder ammunition and chrome-plated chambers showed reliability rates comparable to the best military rifles. Environmental testing revealed both strengths and weaknesses in the M16 design. The rifle's aluminum and plastic construction proved to be highly resistant to corrosion and dimensional changes, outperforming the M14 in high humidity and saltwater environments. However, the M16's direct gas impingement system was more sensitive to fouling than traditional gas piston designs. The 1st Infantry Division's experience with the M16 in Vietnam provided valuable insights into the rifle's performance under actual combat conditions. The Big Red One had been one of the first divisions to receive M16s in significant numbers, and their combat experience helped identify both the rifle's advantages and its limitations. Lieutenant Colonel William Collins, who commanded the division's 2nd Battalion, 16th Infantry Regiment, filed comprehensive reports on his unit's experience with the M16 during operations in War Zone C during early 1966. Collins' battalion had been equipped with a mix of M14 and early M16 rifles, providing direct comparison data under identical combat conditions. The weight advantage of the M16 proved to be significant during extended operations in difficult terrain. Soldiers carrying M16s were able to maintain higher march speeds and showed less fatigue during multi-day operations. The lighter rifle was particularly advantageous during helicopter assault operations, where weight limitations were critical. Magazine capacity differences were immediately apparent during firefights. M16-equipped soldiers could maintain higher rates of fire during the critical opening phases of engagements, while M14-equipped soldiers were forced to reload more frequently. The psychological effect of sustained automatic fire was also significant, with enemy forces showing greater reluctance to maintain contact with M16-equipped units. However, the early M16 Foot-S reliability problems created serious tactical disadvantages. Collins reported that his unit's M16s had jamming rates of approximately 8% during firefights high enough to affect unit combat effectiveness. Several casualties were attributed directly to rifle malfunctions during critical moments in engagements. The ammunition weight advantage became even more important during extended operations. A basic load of 540 rounds of 5.56 ammunition weighed significantly less than 280 rounds of 7.62 NATO, allowing soldiers to carry more ammunition or other essential equipment. This advantage was particularly important for units conducting long-range patrols or operating without regular resupply. The United States Marine Corps was initially more resistant to adopting the M16 than the Army, partly due to institutional conservatism and partly due to their positive experience with the M14 in earlier operations. However, the realities of Vietnam combat eventually forced the Marines to embrace the lighter rifle, and their transition experience provided additional insights into the M16's capabilities. Colonel James Webb, who would later become Secretary of the Navy, served as a rifle company commander in Vietnam during the Marine Corps' transition from M14 to M16 rifles. Webb's unit received their first M16s in March 1967, and the transition period provided direct experience with both rifles under identical combat conditions. The Marines' initial reaction to the M16 was mixed. The rifle felt insubstantial compared to the solid M14, and many Marines questioned whether the smaller cartridge would provide adequate stopping power. However, combat experience quickly demonstrated the advantages of the lighter weapon in the confined quarters and rapid movement that characterized much of the fighting in Vietnam. Webb's company participated in Operation Prairie 4, a major engagement in the demilitarized zone during April 1967. The operation provided extensive combat experience with both rifles, and the results strongly favored the M16. Soldiers armed with M16s were able to maintain higher rates of fire during contact, and the rifle's lighter weight was a significant advantage during the rapid movement required by Marine Corps tactics. The Marines' methodical approach to the M16 transition included extensive training on the rifle's maintenance requirements and operating characteristics. Unlike the Army's initially inadequate training program, the Marines implemented comprehensive instruction that addressed the M16's specific maintenance needs and operating procedures. Marine ammunition logistics also benefited from the switch to 5.56 ammunition. The lighter cartridges reduced helicopter lift requirements for resupply operations, while the smaller ammunition allowed more rounds to be stockpiled at forward bases. These logistical advantages were particularly important for Marine units operating in remote areas with limited supply lines. United States Army Special Forces units were among the first to recognize the M16's potential for unconventional warfare operations. The rifle's lightweight and compact size made it ideal for the kind of long-range reconnaissance and direct action missions that characterized Special Forces operations in Vietnam. Major Charles Beckwith, who later founded Delta Force, commanded Special Forces Operational Detachment A502 during 1966 and 1967. Beckwith's team was among the first Special Forces units to receive M16 rifles, and their experience provided crucial feedback about the rifle's suitability for special operations use. The M16's advantages for Special Forces operations were immediately apparent. The rifle's lightweight was critical for teams that might carry equipment for weeks during long-range patrols. The compact size was advantageous for operations in confined spaces or when rapid movement was required. Most importantly, the rifle's reliable automatic fire capability provided the heavy firepower needed for break contact drills. Beckwith's team modified their M16s for special operations use, including the addition of Colt scopes for precision shooting and sound suppressors for night operations. The rifle's modular design made it easy to adapt for different mission requirements, and Special Forces units became innovative users of M16 accessories and modifications. The 5.56 ammunition's weight advantage was particularly important for Special Forces operations. Teams conducting extended patrols could carry significantly more ammunition than would have been possible with 7.62 NATO rounds, providing greater operational flexibility and endurance. The smaller ammunition also took up less space in equipment loads, allowing teams to carry other essential items. Special Forces experience with the M16 also provided early feedback about the rifle's maintenance requirements in tropical conditions. The direct gas impingement system required more frequent cleaning than traditional rifles, but Special Forces personnel were generally more technically sophisticated than regular infantry and were able to maintain their weapons properly. The 1st Cavalry Division, Airmobile, represented a new approach to warfare that took advantage of helicopter mobility to rapidly deploy infantry forces throughout the battlefield. The division's experience with the M16 demonstrated how the rifle's characteristics complemented air mobility tactics and provided capabilities that weren't available with heavier weapons. Lieutenant Colonel Harold Moore's 1st Battalion, 7th Cavalry Regiment was one of the first air mobility units to use M16s in major combat operations. The battalion's experience during the Battle of Ia Drang in November 1965 provided crucial data about the rifle's performance in high-intensity combat against regular North Vietnamese forces. The M16's weight advantage was critical for air mobility operations. Helicopter lift capacity was limited, and every pound of equipment affected the number of soldiers that could be transported in a single lift. The M16's 4-pound weight advantage over the M14 allowed more soldiers to be carried per helicopter, increasing the combat power that could be delivered to landing zones. The rifle's automatic fire capability proved to be essential during air assaults against defended positions. The ability to immediately lay down high volumes of suppressive fire upon landing was often decisive in preventing enemy forces from effectively engaging incoming helicopters. The M16's controllable automatic fire allowed individual soldiers to provide the kind of suppressive fire that previously required crew-served weapons. Ammunition logistics for air mobility operations strongly favored the M16. The lighter 5.56 ammunition could be more efficiently transported by helicopter, allowing commanders to maintain higher ammunition levels at forward landing zones. The reduced volume of the smaller ammunition also allowed more rounds to be stored in the limited space available on helicopters. The 1st Cavalry Division's experience also demonstrated the M16's effectiveness against enemy personnel wearing light body armor or equipment. The high-velocity 5.56 bullets' tendency to fragment after impact created devastating wound channels that were often more immediately incapacitating than the larger but slower 7.62 NATO bullets. North Vietnamese and Viet Cong forces were quick to recognize the M16's different characteristics and to adapt their tactics accordingly. Enemy after-action reports and captured documents revealed that Communist forces had developed specific procedures for engaging M16-equipped American units, based on their understanding of the rifle's capabilities and limitations. The most significant tactical adaptation was the enemy's recognition that the M16's lighter ammunition allowed American units to sustain higher rates of fire for longer periods. This led to changes in enemy engagement patterns, with Communist forces placing greater emphasis on quick, violent attacks followed by rapid withdrawal rather than sustained firefights that would favor American firepower advantages. Enemy forces also adapted to the M16's longer effective range compared to submachine guns and assault rifles typically used by Communist forces. North Vietnamese tactical manuals captured during operations near Khe Sanh included specific instructions for engaging M16-equipped American forces, emphasizing the importance of closing to ranges under 100 meters where the Communist forces' heavier caliber weapons would be more effective. The M16's distinctive sound signature also influenced enemy tactics. The rifle's high rate of fire and characteristic sound made it easy for enemy forces to identify American positions and estimate unit sizes. This led to the development of sound discipline procedures by American forces and the use of captured enemy weapons to obscure unit capabilities during reconnaissance operations. Communist forces were particularly interested in capturing M16s and ammunition, both for intelligence purposes and for use by their own forces. Captured M16s were often sent to North Vietnam for technical analysis, while serviceable rifles were sometimes used by elite reconnaissance units operating against American installations. The Vietnam War provided the most comprehensive combat testing of American small arms in the nation's history. The experience with the M14, M16, and specialized weapons like the CAR-15 and T-223 offered valuable lessons about rifle design, manufacturing, and employment that would influence American small arms development for decades. The M14's failure in Vietnam was multifaceted, involving design limitations, manufacturing problems, and fundamental mismatches between the weapon's capabilities and mission requirements. The rifle's weight, limited magazine capacity, and uncontrollable automatic fire made it unsuitable for the kind of combat that characterized most engagements in Vietnam. However, the rifle's accuracy and long-range performance remained superior to its successors in specialized applications. The M16's troubled introduction demonstrated the importance of comprehensive testing and proper training before fielding new weapons. The ammunition powder change and lack of chrome plating were preventable problems that cost American lives and damaged confidence in military procurement procedures. However, once these problems were corrected, the M16 proved to be an effective combat weapon that provided significant advantages over its predecessors. The international connections revealed by the Vietnam experience, from German engineering in the T-223 to Japanese precision in the Colt scopes to Italian contributions to NATO standardization, demonstrated the increasingly international nature of defense technology development. No single nation possessed all of the expertise needed to develop optimal weapon systems, and successful programs increasingly required international cooperation and technology sharing. The CAR-15 program proved that specialized variants of successful designs could provide significant capability improvements for specific mission requirements. The willingness to modify basic designs for specialized use became a standard approach for American small arms development, leading to the extensive family of weapons derived from the basic M16 design. Manufacturing lessons from the Vietnam experience influenced American defense industrial policy for decades. The importance of maintaining multiple production sources, the need for surge capacity planning, and the critical role of quality control in high-volume production all became standard considerations in defense procurement planning. The human cost of the small arms problems encountered in Vietnam provided sobering reminders of the importance of thorough testing and proper support for weapons fielded to American forces. The soldiers, Marines, airmen, and sailors who carried these weapons in combat deserved the most reliable and effective equipment that American industry and engineering could provide. When those standards weren't met, the consequences were measured in American lives. The small arms lessons learned during the Vietnam War continue to influence American military equipment and doctrine today. The M16 family of rifles, despite their troubled introduction, evolved into one of the most successful and widely used small arms systems in history. The basic AR-15 design has spawned dozens of variants and continues to be the foundation for American infantry weapons more than 60 years after its initial development. The international cooperation that began during the Vietnam era expanded dramatically in subsequent decades. German engineering expertise, Japanese manufacturing precision, and Italian ammunition technology became integral parts of American defense programs. The global nature of modern defense technology development can be traced back to the international connections that were first established during the Vietnam conflict. The emphasis on lightweight, reliable, easy-to-manufacture weapons that emerged from Vietnam experience became the standard for all subsequent American small arms programs. The lessons learned from the M14's complexity and manufacturing problems led to design philosophies that emphasize simplicity, reliability, and production efficiency over theoretical performance advantages. The Vietnam experience also established the importance of comprehensive field testing before weapons are deployed to combat forces. The problems with early M16s led to testing protocols that require extensive evaluation under realistic conditions before new weapons are approved for production. These procedures, while sometimes criticized for slowing development, help ensure that American forces receive weapons that will function reliably under combat conditions. The story of Vietnam-era small arms represents both the challenges and opportunities of rapid military technological development during wartime. The willingness to adopt new approaches and technologies, combined with the ability to quickly identify and correct problems, ultimately produced weapon systems that served American forces effectively throughout the remainder of the 20th century and into the 21st century. The soldiers, Marines, airmen, and sailors who fought in Vietnam with these weapons, whether struggling with jamming M16s or appreciating the advantages of reliable rifles, deserve recognition for their service and sacrifice. Their experience under fire provided the feedback that ultimately led to improved weapons for future generations of American service members. The international cooperation that characterized Vietnam-era small arms development, from Hacko's precision optics to Harrington and Richardson's German-inspired rifles, established patterns of cooperation that continue to benefit American forces today. The willingness to adopt good ideas regardless of their national origin became a hallmark of American defense technology development. The Vietnam War's small arms story is ultimately one of adaptation, innovation, and international cooperation under the pressures of combat. The weapons that emerged from this crucible, refined through combat experience and improved through technological innovation, provided American forces with capabilities that were unmatched anywhere in the world. The lessons learned, both technical and institutional, continue to guide American small arms development today. The legacy of Vietnam-era small arms development extends far beyond the specific weapons involved. The testing procedures, manufacturing techniques, international cooperation protocols, and user feedback systems developed during this period became the foundation for modern defense procurement. The willingness to rapidly identify and correct problems, combined with openness to international technological cooperation, remains essential for maintaining American military technological superiority. Today, as American forces face new challenges and threats around the world, the lessons learned from Vietnam-era small arms development remain relevant. The importance of reliable, lightweight, easy-to-manufacture weapons continues to guide design decisions. The need for comprehensive testing and user feedback remains critical. Most importantly, the recognition that good ideas can come from anywhere in the world continues to drive international cooperation in defense technology development. The story of American small arms in Vietnam, from the M14's brief service to the M16's troubled introduction to the specialized excellence of weapons like the CAR-15 and T-223, represents a chapter in American military history that demonstrates both the challenges and the opportunities of rapid technological change during wartime. The weapons that emerged from this experience, refined by combat and improved by international cooperation, provided the foundation for American infantry weapons for generations to come.